Okay, the pigeonhole principle. So truly is the number of birds going into holes. So if I have one bird going into 3 holes, there's gonna only be one bird in that hole. But if I have 4 birds trying to go into 3 holes, if the number here in the domain is larger here than the number in the codomain, then for sure I'm gonna have more than one bird in a hole. Okay, so let's see if we can figure these out. If I have 6 people, do there need to be 2 people who have the same birth month? So I can think of the codomain as the 12 months of the year, and I've got 6 people. So no, because this number is smaller. So you can think of these 6 people I could spread out over the first 6 months of the year. So no. All right, so here we have 10 black and 10 white socks. You reach in and you pull in without looking. What's the least number of socks that you can pick so that you get a match? So here I've got 20 socks in the domain, and I've got 2 colors. So for sure, I'm going to have there's going to be more than one in each of the color sets. So how many do I have to pick? So if I pick, just think worst case scenario, I pick 2 socks and it's a white and a black. So how many do I need to make sure I get a matched pair? 3. Just go pick one more and then you'll have 2 socks in the same hole or 2 socks of the same color. All right, here we go. So we've got these numbers. I'm now going to pick 5 integers, and is one of the pair have to have a sum of 9? So let's find the pairs of 9. So the pairs that make 9 would be 1 and 8, 3 and 6, 2 and 7, and 4 and 5. Okay, so if I'm picking 5 and pairs, right, out of the 4 sets that have a set of 9 will, oh, sorry, I did that wrong. If I'm picking 5 integers, okay, I'm picking 5 integers, not pairs. I'm picking 5 different integers. So think of worst case scenario. So I pick this number, this number, this number, this number. Oh, I have to be able to pick this number. So I've got a pair for sure if I'm choosing 5 of them, right? Because here the domain would be the number of numbers and the codomain would be the 4 sets, right? So for sure there's if there's 5 chosen, I've chosen 1 pair. So if there's 4 integers chosen, so my domain is 7, right? And I'm going to pick 4 integers. Do I need to at least have 1 pair? No, because I can do this worst case scenario, right? I can pick 1 from each of the first 4 pairs, so no. All right, so let's generalize this. So the number in X, that would be the number in the domain, and number in Y would be the number in Y, and the codomain, or the number in the range, right? So here's the number K. So if the number of X is bigger than K times the number in Y, then there'll be K plus 1 elements of X that go into a Y. So they're going to be like K plus 1 pigeons, right, going into the holes. So let's use this for this principle here. So if I have 85 people, do 4 of them have the same last initial? So the number in the domain is 85 people, and the codomain would be the 26 letters in the alphabet. Okay, so here I'm looking at 85 here, 26 here, and I know that 3 times 26 is 28. So this number here, 3, is the letter K. So 85 is bigger than 28, and I can't go bigger. And so that means I've got to have K plus 1, or 4 people that have the same last initial. Again, you could think about, for the 85 people, place 1 in each of the 26 months, right? And then start wrapping around with 2 in the 26 months, 3 in the 26 months, and then I'm going to have a few more that are going to have 4 in that same month. Okay, so what you can use is to think about the ceiling. So if I take n, the number in the domain, divided by m, the number in the codomain, then that number, the ceiling of that number will be k plus 1. So if I take 85 divided by 26, I get 3.26. So that means this is k, and this is k plus 1. Whoops, kind of messy there, sorry. This is k plus 1. Okay, so let's do this one. In a group of 40 people, so that's n equal 40, must we have same that were born in the same month? So then the m is 12, right? So if I take the ceiling of 40 divided by 12, n divided by m, that gives me 3.33. So that number is 4. So that means yes, 4 people have the same birthday month. Okay, and then if I chose to do it the other way using this, so the number in the domain is 40, bigger than k times the number of months, so 12. Here, k would be 3, and so that means k plus 1 is 4. So yes, there are 4 people. So it's the same idea, whichever way you prefer to do it. Okay, so here we have 7 colors to paint 50 bikes. So n is 50 for the number of bikes, and m is 7 for the number of colors. So 50 divided by 7 gives me 8. And so that means 8 is k plus 1. So yes, 8 bikes do have 8 bikes do have the same color. So if I take 50 and make it equal to, or bigger than k times 7, so that would mean k would be 7, right? Wait, k would be 8. 7, no, it's 7. K is 7, and so k plus 1 is 8. So there we get the same answer. All right, so let's look at this one. If I have, how many friends must you have to guarantee at least 5 of them will have the same birthdays in the same months? Okay, so our job is to find the number n in the domain. So that's like saying n divided by 12 is equal to 5. So then I know that 5 is equal to k plus 1. So I have n divided by 12. I'm sorry, so that means k is 4, right? And that's the same thing as saying n divided by 12 is bigger than 4, so n must be 48. So, or bigger than 48, so that must mean we have n is 49. All right, let's do that same thing here. So if I need to find n people, so how many people, right? And I've got 12 name combinations because I've got 1, 2, 3 first names, 1, 2, 3, 4 last names. Okay, so that means n divided by 12, which is 2, right? At least 2 people, so I want that to be 2. So that's k plus 1, then k must be 1. So that means n divided by 12 is bigger than 1, so n has to be bigger than 12. So that must mean that n is 13. So that's the number of people that you would need to pick to make sure they have the first same last and first names. Sorry. Okay, so here we go. We've got 40 students in a class, and all the students are known to be between the ages of 17 and 34. So age groups, 34 minus 17 plus 1, that gives me 18 ages, right? Age groups, I should say. Okay. So how many students am I picking? I've got 40 students, and I've got 18 age groups. So 40 divided by 18, the ceiling of that would be 2.22, so that's 2. So that's 3. Ceiling of that is 3. So that's k plus 1. And so I want, no, that's, step. Right, so 3 is equal to k plus 1. So that means if I spread out the 18 students over the 40 students over the 18 age groups, I'm going to have 2 in each group with some more into others. So I'll have at least 3 in some of the age groups. So how large can you make your bet? You can make it as big as 3. So bet 3. That would be the biggest you would want to go. Okay, so here we go. So we've got pennies in this age group, and this age group. So I've got 3 age groups. And I want to know how many pennies. And how many pennies do I want to pick? So make sure that you're getting 5 pennies from the same year. Okay, so I want 5 pennies from the same year. So I'm going to take the number in the domain and divide it by the number in the codomain, and I want that to be 5. So that means n divided by 3 has to be bigger than 4. So n has to be bigger than 12. So you have to pick 13 of them.